In 1968, a team of hydrologists in West Virginia were given 11 months to answer one question. Where does the water go? Not a flood. Not a contamination event. Not an emergency. Just a creek. An ordinary-looking creek, flowing through rolling pasture in Greenbrier County, that did something creeks are not supposed to do. It disappeared into the ground. Then it came back up. Then it disappeared again. Then again. For separate times, the same creek, vanishing into limestone and reappearing somewhere downstream, before finally surfacing for good at a spring so large it is the biggest in the entire state. The hydrologists needed 11 months, and colored dye, just to prove that the water going in on one side was the same water coming out on the other. This is the story of what's underneath that pasture. And why, more than 50 years later, large sections of it have still never been walked by a human being. Greenbrier County, West Virginia, does not look like a place with secrets. It looks like bluegrass pasture. Open, rolling, dry farmland, the kind of landscape that has supported cattle and sheep grazing for 2 centuries. Locals have lived here, farmed here, raised horses here for generations. Nothing about the surface suggests anything unusual. That is exactly the problem. Because beneath that pasture, in the limestone bedrock that the entire region sits on, there are more than 2,000 documented caves. 14 of them are longer than 10 kilometers. Combined, those 14 alone stretch nearly 400 miles. The county has been described by the cavers who have spent 70 years mapping it as one of the most extensive cave networks in North America. And almost none of it is visible from above. This is what geologists call karst terrain, landscapes sitting on limestone, a rock that slowly dissolves when acidic water moves through it. Over millions of years, that dissolution carves cracks into channels, channels into passages, passages into cave systems. The surface above looks normal, solid, walkable. The ground underneath is hollow. Here is the creek at the center of this story. It starts in a place called Richland, in eastern Greenbrier County. It is called Milligan Creek. For the first stretch of its life, it behaves like any other creek, flowing across the surface, visible, ordinary. Then it reaches the limestone. And it sinks. Not metaphorically. Literally. The water enters a crack in the bedrock and disappears from the surface entirely. Anyone standing at that point would see a creek bed, and no water in it. The stream simply stops being visible. Underground, the water keeps moving. Through passages no survey has fully mapped. Through cave systems that took cavers years to even partially chart. And at some point downstream, it rises back to the surface, pushes back up through another crack in the limestone, becomes a visible creek again, flows for a stretch, and sinks again. This happens at least 4 times. 4 documented sink and rise cycles, the creek alternating between visible stream and underground flow, before it makes its final appearance at a place called Davis Spring, near the town of Fort Spring. At Davis Spring, the water that started as Milligan Creek emerges for the last time. It flows less than half a mile before joining the Greenbrier River. And the spring itself is not small. It drains an area of 72 square miles. Its average flow is approximately 110 cubic feet of water per second. It is the largest spring in the state of West Virginia. Most of that water started as a creek you could step over. Before any of this was studied scientifically, it was already known. The grassland surrounding Milligan Creek has a history that predates European settlement by an unknown number of centuries. Historical accounts describe the area as native bluegrass pasture, and not by accident. Native Americans actively managed this land, keeping it clear of forest growth, specifically to attract wildlife. It was maintained grassland in the middle of dense Appalachian forests, kept open deliberately, for hunting. Whether they understood what was happening beneath their feet, whether they knew the creek disappeared and reappeared, whether that mattered to how they used the land, is something the historical record does not say. What is documented is this: long before settlers arrived with surveying equipment, long before anyone had the tools to trace water through limestone, people were living on top of one of the most complex underground drainage systems in the eastern United States, and shaping the surface above it without, as far as anyone has recorded, fully understanding what was below. Then the settlers came, and they used the land the same way, for grazing, for pasture, for raising horses and cattle. The underground geology did not change. The people walking over it did not know to ask about it. The caves beneath Greenbrier County have a documented history of their own, one that has nothing to do with hiking or tourism. Starting in the late 1700s, and continuing through the War of 1812 and the American Civil War, 23 caves in this region were mined for one specific material, saltpeter. Potassium nitrate, the key ingredient in gunpowder. Cave soil, rich in nitrates from centuries of organic decomposition, was harvested and processed into the explosive material that armies needed. The Confederacy, desperate for gunpowder during the Civil War, established elaborate mining and extraction operations in caves across this exact region. At least 22 West Virginia caves were worked this way. The best preserved saltpeter mining operation in the state survives today inside Organ Cave, a short distance from Milligan Creek's underground path. For nearly a century, people were going underground here. Digging. Extracting. Working by lantern light in passages connected to the same limestone system that swallows Milligan Creek 4 times before releasing it. And still, no one had mapped where the water went. The first full technical survey of West Virginia's caves wasn't published until 1949, by a geologist named William E. Davies. Before that, the caves were known, used, even mined, but not systematically documented. Davies's report marked the beginning of organized exploration. Cavers began entering in earnest in the 1950s. Survey organizations formed. The work of actually mapping what was underground had only just begun. It is still going on today. This is where the 1968 investigation comes in. By the late 1960s, hydrologists understood the broad strokes. Milligan Creek sank into the karst, and water eventually emerged at Davis Spring. What they did not know, what no one knew, was the exact path. How long did the water take? Did all of it arrive at Davis Spring, or did some of it go elsewhere? Were the 4 sinking points actually connected to each other in sequence, or was the system more complicated than a single from sink to spring? To answer this, researchers used a technique called dye tracing. The method is direct. Introduce a harmless, traceable dye into the water at the point where it disappears underground. Then monitor every spring, every potential resurgence point downstream, watching for that same dye to reappear. If the dye comes out somewhere specific, you have proven, not theorized, proven, that the underground water at point A is connected to the surface water at point B. It sounds simple. It is not. The investigation into the Davis Spring drainage basin took 11 months. Researchers monitored Milligan Creek and Davis Spring continuously, tracking water stage, temperature, and conductivity, watching for the precise signatures that would confirm the underground connection. Quantitative and qualitative dye traces were performed specifically to establish travel times through the system and to define the true extent of the drainage basin. 11 months. To confirm what a creek's surface behavior had already suggested. Because confirming a connection through solid limestone, proving that water disappearing in one field is the same water rising in another, miles away, requires more than observation. It requires chemical proof. The dye traces worked. Davis Spring was confirmed as the terminus of the Milligan Creek system. But confirming the destination is not the same as mapping the journey. The exact passages, the specific cave conduits the water travels through, between each of the 4 sinking points, remain, to this day, only partially explored. To understand why a creek can vanish 4 times before reaching open water, you need to understand the rock itself. The limestone beneath Greenbrier County is geologically known as the Greenbrier Group, formed during the Mississippian period, roughly 330 million years ago, when this entire region sat beneath a warm, shallow sea. The same kind of marine deposition that built limestone across much of the eastern United States. Compressed shells, compressed coral, compressed marine sediment, transformed over tens of millions of years into thick beds of soluble carbonate rock. That rock does not sit flat and uniform. It folds. It fractures. It has fault lines and joints and bedding planes, structural weaknesses that determined, over 10 million years of water erosion, exactly where the caves would form. Geologists studying the region describe a sinkhole plain sitting atop a complex, interconnected cave network, the end result, as one technical study puts it, of at least a 10 million year history of landscape evolution. The caves are not random. They follow the geology. Strike-oriented passages running parallel to rock layers. Multiple levels stacked vertically, connected by vertical shafts and floodwater channels. A three-dimensional maze that took 10 million years to carve and that humans have been actively mapping for less than 100. The scale of what's underneath becomes clear when you look at individual cave systems in the region. 3 miles from Milligan Creek's watershed, there is a cave called Friar's Hole. Cavers began surveying it in the late 1960s and early 1970s, mapping several miles of passage before moving on to other projects. A second generation of explorers returned in the 1980s, adding new footage. A third generation took up the work in 2014, specifically trying to find an underground connection to Spring Creek, a separate karst drainage system entirely. As of January 2026, Friar's Hole is 55.33 miles long. It straddles the county line between Greenbrier and Pocahontas, with 5 separate entrances on each side. And cavers are still actively pushing new leads inside it, 60 years after exploration began. That is one cave system, in one corner of the county. The Greenbrier Valley as a whole contains more than 2,000 documented caves. And new ones are still being found. This is the environment Milligan Creek disappears into. Not a single simple tunnel. A geological maze that has taken multiple generations of trained cavers, working continuously since the 1950s, to even partially understand. A maze where one creek can sink and rise 4 separate times, and where the precise underground route between those points has been chemically confirmed, but never physically walked, start to finish, by a human being. Here is what should give you pause. This is not a remote, inaccessible wilderness. This is not deep jungle or polar ice. This is rolling Appalachian farmland, in the eastern United States, within driving distance of multiple towns, grazed by livestock for 2 centuries, studied by professional hydrologists since at least 1968, and home to caves that have been entered and mined since before the United States existed as a country. And the precise underground path of a 6.8-mile creek is still not fully mapped. Not because no one has tried. The dye tracing studies are real, peer-reviewed, methodologically rigorous. The cave surveys are ongoing, conducted by trained organizations with decades of institutional experience. The West Virginia Speleological Survey maintains records on thousands of documented caves across the state. This is not a case of nobody looking. It is a case of the underground simply being larger, more complex, and more resistant to mapping than the surface world ever suggested. Davies's first survey, in 1949, described what was known at the time. 77 years later, cavers are still adding new miles to systems like Friar's Hole. The work has not stopped because the work is not finished. Every decade, the maps grow. Every decade, previously unconnected systems are confirmed, by dye, by exploration, by both, to be part of a larger whole. What that means is this: the full extent of what lies beneath Milligan Creek's path, the actual cave passages connecting its 4 sinking points to Davis Spring, may not be something anyone currently alive will see completed. Consider what the dye tracing actually proved, and what it didn't. It proved connection. Chemically, conclusively, the water that sinks at Milligan Creek's upper reaches is the same water that rises, eventually, at Davis Spring. That much is settled science. Not speculation. Not folklore. Measured fact. What it did not provide is a map. Knowing that point A connects to point B tells you the water gets there. It does not tell you the shape of the passage, the chambers it passes through, the chemistry of the rock it has slowly dissolved over 10 million years to make that journey possible. A dye trace confirms a destination. It does not document a route. To document the route requires cavers, people, physically descending into cracks in limestone, mapping by hand, foot by foot, in passages that may be barely wide enough to crawl through, that may flood without warning, that have claimed exploration projects spanning entire human lifetimes. Friar's Hole took from the 1960s to 2026, and counting, to reach 55 miles. And Friar's Hole is a separate system from Milligan Creek's path. The Milligan Creek conduits, the actual passages between the 4 sink points, remain less explored still. The water has made the full journey, 4 sinks and 4 risings, every single day, for longer than any human record exists. No person has made that same journey, start to finish. There is a particular kind of silence in knowing something is true without being able to see it. Hydrologists know, with chemical certainty, that Milligan Creek's water travels underground for most of its journey. They know the destination. They know the approximate timing, established by those 11 months of monitoring in the late 1960s. What they do not have, what no one has, is a complete physical map of the passages themselves. Somewhere beneath that bluegrass pasture, in total darkness, water that fell as rain in Richland, West Virginia, is moving through limestone corridors carved over 10 million years, passing through spaces no light has ever illuminated, on its way to becoming the largest spring in the state. It has been making this journey since long before Native Americans cleared the grassland above it. It will keep making this journey after every cave survey currently underway is finished, and after the surveys that come after that. The creek sinks. The creek rises. The creek sinks again. And the precise path it takes, in the dark, beneath the open pasture where cattle graze and have grazed for 200 years, is still, even now, only partially known. This channel follows the water, and what it reveals when it disappears. The next story begins somewhere else. The surface doesn't tell the whole truth. That story is already in the works.